Greetings, this is Kabwama Ronald, presenting my data communication coursework tool. The first question was to define the following terms, and the first term was frequency division multiplexing. This is a technique of multiplexing, meaning we are combining different signals into one transmission. And in frequency division multiplexing, signals of different frequencies are combined into one, and then you can transmit them under concurrent transmission. So what we do, we break the bandwidth of the transmission into individual frequencies, and we make sure that these frequencies act as carriers for the signals we are transmitting. The second question was about the wavelength division multiplexing. Here we combine signals or optical light signals into one by defining their wavelengths. It's commonly used when we are transmitting data over telecommunication companies where they use fiber optical cables. So what they do, they combine different light spectrum colors which have different wavelengths, and then they can transmit that data from one end to another. We also have the third one was synchronous time division multiplexing. This is a type of multiplexing where signals or every transmitting device is allocated a time slot in the transmission carrier. So what we do, we make sure that every carrier which is transmitting the signal can transmit data for every channel which is sending the information. It's contrary to statistical time division multiplexing, which now dynamically allocates time slots to the transmitting channels, whereby in case a channel is not ready to send any data, it's not given a time slot. But for synchronous, they are allocated so long as it's a channel in the communication. The fourth one was interleaving. Interleaving is a tool which is used in correcting burst error codes. So what we do, we provide a situation where we have two switches, one at the sending end and one at the receiving end. So what it does, when you are sending information, it opens to the link which is ready to send the information for the sending side, and then the other side, it also opens for the link which is targeted to receive the information. Now what reduces the error is that information flows from the incoming link to the appropriate receiving link, so it reduces the data loss. The second question was still to define the following terms, and the first term was frequency hopping spectrum. It's a method of transmitting radio signals by rapidly changing the carrier frequencies among the distinctive frequencies which are occupying a spectrum band. So when we are transmitting information, we make sure that information is spread along the carrier frequencies or the frequencies which can help us to transmit the signals. So those signals are controlled by codes only known to the sending side and the receiving side. We also have another term which is orthogonal frequency division multiplexing. It's a type of digital multiplexing or digital transmission whereby a method of encoding digital data on multiple carriers is used when we are using multiple closed spaced orthogonal subcarriers. So we get one, and then we divide that carrier into subcarriers, which are of course not overlapping, so that information can be sent in parallel. We were also asked about the intersymbolic interference. When we are sending information, of course, the light signals tend to disperse when they are traversing the transmission media. So what it does, this error or this defect can make the receiving node, of course, failing to differ between two signals being sent over the media. And that effect is what we call inter-symbol interference. The last one was the universal quantization. This is a type of quantization in which the quantization levels are uniformly spaced. So it mostly has two media types, which is mid-rise type and a mid-tweed type. And when you want to illustrate them, they specifically resemble the stairs, the way steps are arranged, whereby information flows from down to up when those levels are uniformly spaced. Thank you very much, sir. That's the presentation for the first question.